Hey everyone, I'm Nick, and this is Software Development with C++. So in this episode of the series, we're going to be talking about the basics of static and dynamic linking. So it's often the case we want to use code that's been implemented as part of some library, and a great example of this is things from our C++ standard library. Now, the way that we use this code is through linking. So we'll have to link against this library to get access to the code that we want to use. And there's two major forms of linking, right? There's static linking and there's dynamic linking. So we're going to be looking at the basics of these two forms of linking today and how they differ with a very simple example. So our simple example here is just going to be this main.cpp file. And it really is just a hello world program, right? So we just have a main function that prints using stdcout hello world before returning 0. But we're going to see the difference of how we can compile this by dynamically linking against our standard library versus compiling it where we statically link against our standard library. So by default, right, when we try to compile an executable with something like G++, we will automatically dynamically link against our standard library. So if I do something like G++ pass main.cpp and try to create an executable called main dynamic, right, this is automatically going to dynamically link against our standard library. Now we can change this and we can tell our compiler or compiler driver that we want to statically link against this our standard library. In the case of GCC, that'll be libstdc++.so. So we can tell our compiler we want to do that through a simple flag here. So let's go ahead and change our output executable to main static, and we'll pass this flag dash static libstdc++, right? And you can see here we've created two different executables here. So we can run both of these and we see that, they give us the same result. They're both going to print out hello world, but where the difference really lies is underneath the hood. So the first thing we can look at is the dependencies that these two executables have, right? Specifically the dependencies on shared libraries. So one of the ways we can inspect that on Linux machines is through the tool LDD. So we can do LDD on something like main dynamic to get a list of the dependencies. And you can see here that, as part of this, list of items here, these shared libraries, we depend on this libstdc++.so, and it gives us the location of this shared library. So this is our implementation of our shared library here. So if we want to run this executable main dynamic, our dynamic linker is going to need to be able to find, right, this shared library here, right? We're relying on the implementation of things that are contained within this libstdc++.so. However, a major difference we have, right, with our statically linked example, so if we go ahead and, do LDD on main static, you see we no longer depend on libstdc++.so, right? We have a few of the other shared libraries here that are not statically linked, but we no longer have libstdc++.so, right, in this list of dependencies. So what exactly does this mean? Why do we no longer have this here? Well, because we statically linked this second example here, right, this main static, this means that we grabbed the information that we needed from that standard library and we built it into our executable here. So we no longer need access to this libstdc++.so at runtime here. So one of the major differences between static and dynamic linking, with dynamic linking, right, at runtime, we'll need to load the code that we need from our shared library for our executable, but with static linking, that code is already built in as part of our executable. And another way that you can kind of see this is by just inspecting the size of our two executables here. So if we do ls-la, you can see that our statically linked code is, way larger than our dynamically linked code, right? And that's because the things that we needed from libstdc++ are built into this executable now, this main static. While in this main dynamic, they still live in that libstdc++.so, that shared library. So we'll just load those at runtime instead of just having them built in as part of our executable. So another thing we can do here is we can disassemble these two executables and see a bit more about what's going on underneath the hood. So let's go ahead and use object dump or objdump to disassemble our executable here. So we'll do -dc to disassemble and demangle the names. And first we'll do main dynamic, right? And we'll just redirect the output to some, file called outDynamic.s, and then we'll do the exact same thing, but for our statically linked example here. So this main static. And then we can go ahead and open up these two disassembled files here. So we'll just do vim.o, and we'll open up outDynamic and outStatic here. Okay, so here's our two disassembled executables here. Let's go ahead and move over to where the main function, right, where the main kind of method is in here. So we'll move over here on both, and we can see that they look, fairly similar and pretty much exactly the same here, right? Just a few minor differences. So we still have, some load effective address here for stdcout, right? Although we see here that there's a stdcout at this glib cxx 3.4, while we just have stdcout right in our statically linked version. And then we have our call, right, on both of these to our operator less than, right? So that's what we're using to print our hello world string. So let's go ahead and just follow the follow this address here that we're calling, right? So we're doing this call 1080 in our dynamically linked example. So we'll go ahead and follow that. And then we'll also follow this 70A30 here, right, for our statically linked example. And we see something very different. Inside of our dynamically linked example, right, you can see that we have this little @plt appended to the end of this, operator less than, and this PLT stands for this procedure linkage table. And you can see instead of having, say, a full function here implementing, this operator less than, right, this print for our, our cout. Instead, we just have a stub of a function here, and that's because the actual implementation of this function is not contained within this file. So we use things like this, this procedure linkage table and this global offset table in order to jump to the correct function at runtime, right, after our dynamic linker and has loaded this information from our shared library. But in the case of our statically linked example, right, which is going to be the one on the bottom here, you can see we just have the implementation of this function, right? It's statically linked. We grab the information we needed from libstud c++.so, and it's built in as part of our executable, right? Okay, so these are some of the differences between, static linking and dynamic linking. Kind of the core difference here is where the code that we're trying to access from this library lives, right, with respect to our final executable. In the case of dynamic linking, right, the code from the library still lives as part of, say, some shared library, and we load it, right, at runtime, right, when we need to use it. While in the case of our statically linked example, we just build in that code as part of an executable, and it kind of breaks that dependency. And as you can imagine, there are a number of different trade-offs here. So there's trade-offs related to the time it takes to load things from shared libraries in the case of dynamic linking, but there's also trade-offs related to the executable sizes we have with static linking, right, and having to load the entirety of these large executables. But that's kind of the basics of the static and dynamic linking. We'll talk about this a lot more in later videos, especially when we get into building our own shared libraries and linking against those. As always, you can find this and any of my other examples at github.com/coffeebeforearch, but that's going to go ahead and do it for today. As always, I'm Nick, and I hope you have a nice day.